Hello dear students, from this class onward I will be discussing about the optics, particularly the physical optics. That is, the light will be considered to be a wave, it will have some wave nature. I also believe that you have the concepts of basic waves from the previous classes on this particular paper. You have the idea of the phase velocity, the group velocities, which will be very much required in these particular classes. You have also studied in your higher secondary classes that the propagation of light, considering the wave nature, has been explained from the Huygens principle. Again, Huygens principle requires the concept of wavefront, the phase. So let us start our discussion particularly on light as a wave and the Huygens principle. So first of all, we will be discussing about the Huygens principle, and then we will be moving on to our other required issues. So I will recall the definition of phase, which I believe that you have already studied. So what do I mean by a phase? So phase bolte amra ki bujhi? So phase, you know that it is the state of vibration of the system at any particular instant of time. So it is the state of vibration at any instant t and position x. So if you know the phase, you know all the information of a particular wave. So let me write it. State of vibration at any instant of time, t and position x in one dimension, right? So that is what is the phase. We know that the phase velocity is given by dx by dt. The concept has been explained in details to you. Details e amra explain kore diyechilam je phase velocity concept kotha theke kibhabe asche. Next I would like to discuss about the next আমি যেটা আলোচনা করব সেটা হচ্ছে ওয়েভ ফ্রন্ট. So what is a wave front and what are the different types or the properties of the wave front? Wave front তোমরা বাংলা এটাকে বলেছো তরঙ্গ মুখ. That is what is a wave front. So wave front এর definition আমরা এখান থেকে লিখব. We will write a definition for the wave front. So wave front is particularly a surface so wave front is a surface. Wave front is a surface upon which the phase of disturbance, phase means the nature of vibration, upon which the phase of disturbance is same at any instant, upon which the phase of disturbance is same at any instant of time, upon which the phase of disturbance is the same at any instant of time. That means that it is actually it is the loci. So loci is the plural form of locus. Locus তোমরা এটা বাংলায় বলেছো সঞ্চার পথ. So actually it is the locus of points. So you know what is the locus? So there are some points and the point joining curve which is generated is called the locus. So actually it is the loci of points of constant phase. It is the loci of points of constant phase. So how do you try to explain it? So এটা আমরা কি করে explain করতে পারি? So in order to explain this, let us take a point source. So আমরা একটা point source নিয়ে এটাকে explain করার চেষ্টা করি. So in order to explain, don't look at the definition, don't read the definition, I will be explaining it and then you will be reading it once again. আগে আমি explain করে দিই, তারপরে তোমরা আবার একবার পড়বে, তাহলে দেখবে পুরো ব্যাপারটা বুঝতে পারছো. So a wave always travel perpendicular to the wavefront. A wave always travel perpendicular to the wavefront. In case of a point source, in isotropic homogeneous medium, isotropic homogeneous medium. So homogeneous medium means the medium properties is same at all points, and isotropic means it is also independent of the direction. That is, whatever be the angle, so if you view the system at 30-degree angle or if you view the system at 60-degree angle, it will be identical. So that is what do we mean by isotropic system. So in case of a point source in isotropic homogeneous medium, comma, and by isotropic we means that the velocity of the light wave is same in all the directions. So সমস্ত দিকে velocity টা same independent of directions. So in case of point source in isotropic homogeneous media, comma, the wave front is spherical in nature. The wave front is spherical in nature, and the corresponding waves are called spherical waves. Right? So this is the definition of the spherical wavefront. So let us try to understand it in a very simple way. So আমরা একটু সিম্পল ভাবে এটা একটু বোঝার চেষ্টা করি that what do we mean by the spherical wavefront. Suppose this is the source of light, point source, okay, point source, একটাই পয়েন্ট আছে. So waves are emanated from here like this. এরকম ভাবে এখান থেকে waves বেরিয়ে আসছে. So waves are emanated from here like this, okay. Now as the velocity of light is same in all the direction, যেহেতু velocity of light টা সমস্ত দিকেই সেম আছে, it is isotropic medium independent of the angle. So that is why the distance traveled in a time of x is how much? It is ct. So x distance jete, so all of them will travel a distance of ct in a time of t. So t time pore tara kotota distance travel korbe? They will travel a distance of ct, okay. And if I join all these points, ei je points guloke jodi ami join kori, if I join all these points, so then what will happen? If I join all these points like this, so this will result in a sphere. So এটা একটা sphere আসবে. As it is, this board is two-dimensional in nature. যেহেতু এই plane of paper বা board যাই বলো না কেন, it is two-dimension in nature. So you are getting a circle. সেই জন্য তুমি এখানে circle পাচ্ছ. But if it is three-dimension realistic in nature, so you think in your own way. তুমি নিজেই চিন্তা ভাবনা করো. যদি three-dimension হয়, if it is three-dimension, so then this will lead to a sphere. As it is two-dimension, this plane of paper, so that is why it is simply a circle. So you see that as it is so isotropic and homogeneous in an isotropic homogeneous medium, so this means actually that in equal time interval they will travel the same distance. So একই time interval এ তারা same distance travel করবে, and that is why the phase of all these points are the same. সেই জন্য এই প্রত্যেকটা পয়েন্টের ফেজ কি হবে? তাদের প্রত্যেকের ফেজটা সেম থাকবে. They will have the same phase. All of these points will have the same phase over here, same state of vibration, right? Because after a time t, all of them has obtained the same nature. So time t যাওয়ার পরে সবাই একটাই particular nature পেয়েছে. So phase is actually the state of vibration. So after a time t, all of them will attain a particular state of vibration. Particular state of vibration মানে এটা যদি ওয়েভটা হয়, if this is the wave, so ধরে নাও after t time, so this is the point, মানে এটা একটা maxima point. তাহলে যেই দিকেই যাক না কেন, whatever be the direction, all of these points will correspond to this type of maxima. That means that all of these points are at same phase. So wavefront এমন একটা সারফেস যেটার উপরে সবগুলো পয়েন্ট সেম ফেজে থাকে. All the points are in same phase on the surface of a wave front. I hope that this actually helps you to understand. Not necessarily the maxima, it can be this point also. So ধরে নাও after a time t, it attains this particular disturbing point. So a particular disturbing point এসেছে. So all these points are corresponding to that particular disturbance. So এখানে প্রত্যেকটা পয়েন্টই এই সেম ডিস্টারবেন্সটা indicate করে, it indicates the same disturbance over here. So that is how a point source actually leads to a spherical wavefront. So point source থেকে আমরা spherical wavefront পাই. So from a point source we actually get a spherical wavefront. In the same way, if it is a linear source, যদি linear source হয়ে থাকে, so from the linear source we will try to get a cylindrical wavefront. So linear যদি সোর্সটা হয় মানে একটা স্ট্রেট লাইন যদি হয়, if the source is just a straight line, so from here we will get some cylindrical wavefront. So এখান থেকে আমরা cylindrical wavefront আমরা পাবো, we will get cylindrical wavefronts from here. So that is the basic idea that we are trying to discuss. তো সেটাই আমরা এখানে ডিসকাস করার চেষ্টা করছি। I hope that these are properly understood by you. So আশা করি এই জায়গাগুলো তোমরা প্রপারলি বুঝতে পারলে that spherical wavefront conceptটা কি। So what is the actual concept of a spherical wavefront, and when do I actually have the that linear wavefront? So for the linear sources you have the cylindrical wavefront. Okay, so let me just try to draw over here. So আমরা এখানে একটু draw করার চেষ্টা করছি that what do I actually mean by all of them. We may write next that এরপরে আমরা লিখতেই পারি যে in case of linear source, in case of linear source, the wavefront is cylindrical. The wavefront is cylindrical. The wavefront is cylindrical because all the points which are equidistant, that must be equidistant because they must be at same phase. So same phase is possible when they travel the same distance, which are equidistant from a linear source, which are equidistant from a linear source, because all the points which are equidistant from a linear source lie on the surface of the cylinder, lie on the surface of the cylinder. Let me draw both the situations over here. So এই দুটো কেসই আমরা একটু ড্র করে দিচ্ছি, the situation for cylindrical wavefront and also for the spherical wavefront. So this is the case of the spherical wavefront. So where you see that everything over here, so more or less I have been able to draw it, মোটামুটি একটা আঁকার চেষ্টা করলাম। So this one is your source, suppose S. So এই মাঝখানটাতে source S টা আছে। So this one is the source S, and you see that all of these points are equidistant. এই সবগুলো পয়েন্ট কিন্তু equidistant আছে, all of these points are equidistant as they lie on the surface of the sphere. Basically over here it is circle, এখানে সার্কেলের উপর লাই করছে। So এই সেন্টার থেকে এরা সব একই ডিসটেন্সে আছে, and same distance actually confirms that they are on the same phase. That is what is the requirement of a wavefront. So wavefront হতে গেলে অবশ্যই same phase এ থাকতে হবে, right? Got it? And the light waves actually emanates perpendicularly from the wavefront. That means that if this is the point on the wavefront, so the light wave must emanate in this direction from this particular point. মানে এই পয়েন্ট থেকে এই দিকে বেরোবে না, from this point it will not go in that particular direction. So from every point they emanates in a perpendicular direction. Okay, so that is the idea of the wavefront. And in case of the cylindrical wavefront, so cylindrical এর জন্য, so let me try to do something. So আমি একটু চেষ্টা করছি ড্র করার, I don't know how much I will be able to do it. Just wait, let me try with this. not bad, খুব খারাপ হয়নি। What is the source? It is a linear source, as I have said to you যে আমার সোর্সটা হচ্ছে linear source. So suppose this one is my source, এই যে ব্ল্যাক যে লাইনটা, so this black is the source, এটা হচ্ছে সোর্সটা, ওকে, this black one is my source, এই ব্ল্যাকটা হচ্ছে সোর্স। তাহলে এখানে ওয়েভ ফ্রন্টটা সিলিন্ড্রিক্যাল কেন হলো? why the wave front is cylindrical? So you just have a look over here, you will automatically understand, তোমরা নিজেরাই বুঝতে পারবে এটা সিলিন্ডার কেন হলো। if I consider this particular point, so you see that from this particular point the wave can travel in these directions, so এই সমস্ত ডিরেকশন ওয়েভস গুলো যেতে পারে, it can go in these particular directions. So definitely there is a top surface which is circular in nature, তাহলে একটা টপ সারফেস থাকবে যেটা সার্কুলার ইন নেচার হবে, the top surface will be circular and similar points will be also there on the bottom surface. So bottom surface এও একই রকম ভাবে এরকম থাকবে, so there will be the same case in the bottom surface also, and the same can be repeated all throughout any other points. তো এই জিনিসটা তুমি যে কোনো জায়গাতে রিপিট করতে পারবে, you can repeat for any other points, যে কোনো পয়েন্টের ক্ষেত্রে তুমি এটা রিপিট করতে পারবে, you can repeat it for any other points, and just then what will happen is that you have to draw this type of circles. তাহলে সেই সমস্ত জায়গার জন্য তোমাকে যেটা করতে হবে সেটা তোমাকে এই একের পর এক সার্কেল এরকম ভাবে ড্র করে যেতে হবে, you have to draw this type of circles again and again. So all these circles together actually yield a cylinder. So এইভাবে সার্কেল ড্র করতে করতে ultimately if you draw circles like this, you will get many such circles, and joining all these circles tangentially gives you the wave front which is cylindrical in nature. So I have shown you for the top and the bottom points actually, আমি top আর bottom পয়েন্টটা দেখিয়ে দিয়েছি, বাকিগুলো তোমরা অটোমেটিক্যালি করে নিতে পারবে, the others you can do automatically yourself in a very beautiful manner. So সেগুলো একা একা করে নেওয়া সম্ভব, just put some arrow, so this is the direction of propagation of the waves. ঠিক আছে রে, top আর bottom পয়েন্টটা আমি দেখিয়ে দিলাম। So why, so actually they give circles, so actually তারা সার্কেল দেয়, and then you have many number of such circles throughout the linear source, গোটা linear sourceটা জুড়ে throughout the linearity you have many such circles, and if you join those circles tangentially with the surface, এরকম যদি সারফেস দিয়ে জয়েন করো, so then that yields a cylinder in nature. So this one is the case of spherical wavefront and this one is the cylindrical wavefront. So I may also have another type of wavefront which is called the plane wavefront. So if we take a small portion of a wavefront at a large distance from a source, if we take a small portion of a wavefront, at a large distance from the source, if we take a small portion of a wavefront at a large distance from the source, comma, then the corresponding wavefront is called, plane wavefront, তখন এটাকে আমরা plane wavefront বলবো। Plane waves are used very frequently in our different discussions, because for the plane waves only you can take the beam of light to be parallel. So whenever light is assumed to come from infinity, যখন infinity থেকে কোনো light beam আসে, so that is when we take it to be a plane wavefront under that cases. Try to understand the situation একটু বুঝে নাও in a realistic manner. So suppose this is the point source of light, so this is the wavefront, and then another wavefront, and as you are moving at large distances, so you will have wavefront like this. So এরকম করে তোমার wavefront থাকবে, is it clear? So the beam actually propagates in this particular ways and you have the wavefronts in this way. So এইভাবে তোমার কাছে wavefront থাকলো। Now you just consider the small portion of a wavefront at a very large distance, অনেকটা দূরে এরকম একটা wavefront you consider at a very large distance. Okay, just let me remove all this. Just have a look, this is the last wavefront that I have drawn, right? And you take a very small portion of it. এবং এই ওয়েভ ফ্রন্টের একটা স্মল পোর্শন তুমি যদি নাও, ইফ ইউ টেক এ ভেরি স্মল পোর্শন অফ দিস ওয়েভ ফ্রন্ট অ্যাজ ইট ইজ ভিজিবল নাও, এখন এই যে ওয়েভ ফ্রন্টটা দেখা যাচ্ছে, ইফ ইউ টেক এ ভেরি স্মল পোর্শন অফ ইট, হোয়াট ডাজ ইট অ্যাপিয়ার্স টু? So in this two-dimensional board, it appears to be a straight line. A two-dimensional board এটা straight line মনে হচ্ছে. So as you convert it into three dimension, so three dimension এ গেলে এটা কি হবে? So this will just look like a plane. তখন এটা একটা প্লেনের মতন মনে হবে. It will just look like a plane. A plane, right? Plane মানে having a length and breadth. So as it is a two dimension, so যেহেতু আমরা সার্কেল ড্র করেছি, so সার্কেল থেকে কি পাবো? From a circle, a small portion definitely will give you a straight line. Similarly, if you have a sphere, so a small portion of the sphere will give you what? That will give you a plane. So ওইটা তখন তোমাকে একটা প্লেন দিয়ে দেবে, and that plane, that is why we call it a plane wavefront. So সেই জন্য আমরা এটাকে প্লেন ওয়েভফ্রন্ট বলি। প্লেন ওয়েভফ্রন্টস আর বেসিক্যালি ড্রন ইন দিস টাইপ অফ ওয়েভস। সো এরকম ভাবে আমরা প্লেন ওয়েভফ্রন্ট ড্র করি, and I have said that the light waves emanate perpendicular to the waves. So light waves আমরা বলেছিলাম যে কি করে ইমার্জ করে। সো দ্য লাইট ওয়েভ অ্যাকচুয়ালি ইমার্জ পারপেন্ডিকুলার টু দিস ওয়েভফ্রন্ট। সো ওয়েভফ্রন্টের সাথে পারপেন্ডিকুলারলি তারা ইমার্জ করবে, they just emanates perpendicularly. So that is why if the wave emanate this way, এরকম ভাবে যদি waves বেরোয় perpendicularly, so you may just correspond this to parallel beam of light. In geometrical optics, which you have read in higher secondary classes, so geometrical optics light is treated as a ray, and if the waves emanate perpendicularly from the wavefront থেকে যদি এগুলো perpendicularly বেরোয়, if they comes out perpendicularly from here, so this can be just corresponded to what? Corresponded to parallel beam of light. So তাদেরকে parallel beam of light তুমি বলতেই পারো, you can call them parallel beam of light. So hopefully you have understood. So আবারও আশা করা যায় তোমরা এটা বুঝতে পেরেছো that what is the concept of parallel beam of light. So wherever you see some parallel beam of light, you should understand that the wavefront is coming from infinity, and this is approximated to the plane waves, এবং সেটা plane waves বলে আমরা ধরে নিচ্ছি। So plane wavefront means that when there is actually a spherical or a cylindrical wavefront, actually spherical বা cylindrical wavefront ছিল, কিন্তু আমরা এতটাই দূরে আলোচনা করছি as we are discussing at a large distance, so that is why it can be taken to be parallel beam of light. You know that the sun rays are actually taken as parallel beam of light because the sun rays are coming from infinity. Sun ray যখনই কোনো experiment করি, whenever we deal with the sun rays, we take parallel beam of light because the beam of light is coming from infinity. The beam of lights are coming from infinity. That is what you understand in a very simple manner. তুমি ধরো এরকম ভাবে তুমি লাইন টানলে কয়েকটা, you just draw some lines like this, এরকম লাইন টানলে at these regions, এই নিচের দিককার রিজন গুলোতে দেখো, at these regions you see that suppose you are concentrating within this region, এইটুকু জায়গা যদি কনসেন্ট্রেট করো, you see that there is a diverging nature is very much clear. সো এখান থেকে এটা বেরিয়ে যাচ্ছে, সো এখান থেকে এটা বেরোচ্ছে, মানে তাদের মধ্যে দেখো দূরত্বটা বাড়ছে আস্তে আস্তে। the distance between them is gradually increasing as your observing point is over here. Similarly, if the observation point is over here, the diverging nature is more clearly understood, আরো প্রপার ওয়েতে আন্ডারস্ট্যান্ড করতে পারছো। But if you consider a portion over here, you see, বাকি কোথাও কিছু তাকাতে হবে না, you just look at these two portions over here, you see that the lines appear more or less parallel to each other. এখানে দেখো লাইনগুলো কিন্তু মোটামুটি তাদের নিজেদের মধ্যে প্যারালাল বলে মনে হচ্ছে, not diverging but parallel in nature, right? So this is the nature, this is the geometric nature, that you see that although it is a point source, but when the wavefront or the ray of light is examined at a distance which is far apart from the point source থেকে অনেকটা দূরে যখন তুমি কোনো কিছু আলোচনা করবে, when you examine some property at a far apart distance from the point source, then you see that this generally appears to be all parallel in nature. দেখো এদেরকে parallel beam বলে মনে হচ্ছে। So that is the nature, that is the reason that why the light beams coming from infinity, you take it to be plane wavefront or you take it to be parallel beam of light. So that's the idea over here. So এটাই হচ্ছে আইডিয়া এখানেতে, বাস আর কিছু জানার নেই। So nothing else to know. Okay, that is fine. So let me remove this. Right. So by this time you have developed a concept of the spherical wavefronts, the cylindrical wavefronts, and also the plane wavefronts. Okay. Now basically I will go into the Huygens principle. So what is the Huygens principle? So let us try to understand from here. So according to Huygens principle, every point of the wavefront is a source of secondary disturbance. So প্রত্যেকটা point primary wavefront, the first wavefront is the source of secondary disturbances. So from every point of the primary wavefront emerges the secondary waves. Now where from do the concept develop? A concept, এটা তো Huygens principle আমরা জানি, we know that this is the Huygens principle, but you should understand that where from did Huygens get the motivation to formulate this principle? Huygens motivationটা কি ছিল? So until and unless you know the motivation, you will not understand the theory at its best. And it would be also an injustice if it is not being informed to you that how Huygens was motivated to give this principle. যে হাইগেনের অ্যাকচুয়ালি উনি কোথা থেকে বুঝতে পারলো যে এই প্রিন্সিপাল এরকম হতে পারে। The idea is something like that, which will be discussed in the upcoming chapters, particularly during the classes of diffraction. Diffraction, one of the interesting phenomena in physics, in optics, that will be discussed with you as per your requirement. Suppose there is a slit, এরকম একটা স্লিট ধরো তোমাদের কাছে আছে, you have a slit over here, a fine hole or a slit like this. Okay, now parallel beam of light is made to incident over it. So এটার মধ্যে parallel beam of light আমরা এটার মধ্যে incident করতে দিলাম। Parallel beam of light actually incidents on it. This is just a point. Parallel beam of light is incident on it. That is plane wavefront. So what actually happens once the light beam is incident? What actually happens on the screen? What do you expect? What do you expect? I suppose that you have read nothing in these undergraduate classes in optics. আমি ধরে নিচ্ছি optics এ তোমরা undergraduate ক্লাসে এখনো কিছু পড়োনি। So what do you expect over here under these circumstances? So whatever you expect is that light propagates in a straight path, you know, rectilinear propagation of light. So you say that light propagates in the straight line, and that is why you get something of this nature. So actually the light will be in between this region. So এইটুকু জায়গাতেই খালি লাইট থাকবে, আর এই গোটা জায়গাটা, this entire region over here, this entire region, so what will happen to that? So this entire region will be dark, এই গোটা জায়গাটা dark থাকবে, so this will be a shadow and you will have some light only in this portion, এইটুকু জায়গাতেই খালি লাইট থাকবে। But interestingly it has been found that some light also enters in this particular portion, এই জায়গাতেও কিন্তু লাইট এন্টার করেছে, some light enters within the shadow region also, and eventually there is a distribution of that intensity. মানে এই যে শ্যাডোতে যে লাইটটা ঢুকেছে, the light that has entered within the shadow, that intensity is not constant, but there is a variation of the intensity on this shadow region. Shadow regionের যে intensity সেখানে একটা ভ্যারিয়েশনও আছে, there is a variation in intensity within the shadow region. So that is quite an interesting phenomena that we understand over here. So এখানে একটা অত্যন্ত গুরুত্বপূর্ণ জিনিস আমরা দেখতে পাচ্ছি, that within the shadow region you have some light, and there is a distribution of the intensity also. That is, if I plot the intensity over here, and this is the x means this is x equals to 0 and this is some x. So there you will see that the intensity is not constant, but there is a variation in the intensity. So intensity এর একটা variation ওখানে আছে, some maxima minima points are there, and ultimately it vanishes. একটু দূরে গিয়ে আর নেই, after a distance it is not there. But the question is that why light enters within this region? এইটুকু জায়গাতে light cannot glow. Light travels in straight path, so the light shouldn't enter into this region. তাহলে এই জায়গায় লাইট আসার কথা নয়, তাহলে লাইট এখানে কেন আসলো? So why there is some light in this particular portion? So that has been explained by the concept of this wavefront and the Huygens principle. So Huygens over here predicts that the situation is not like that what I have drawn. So আমি যেটা এঁকেছি সেটা situation নয়, that is not the situation. The situation is something else, and this will make you happy. So according to Huygens, these act as a point source, and so spherical wave will be emanated from here. So এখান থেকে spherical wave fronts বেরিয়ে আসবে, there will be spherical wave fronts. And you know that the waves travel in which directions? The wave travel perpendicular to this sphere. So that is why there will be some waves in this direction, there will be some waves in this direction, and that is the reason. So এটাই হচ্ছে কারণ যে কেন এখানেতে why do you have the light in this particular portion? এই জায়গাগুলোতে কেন লাইট আসলো? Because of this particular nature. And the distribution of intensity, that is a different phenomena, that is due to the superposition of the different waves. সেটা তোমার superposition এর জন্য হয়, that is due to the superposition you have this type of effects. Okay, so that is due to the superposition you have this type of effects. So it is called interference that you will study, and this is the interference from the secondary disturbances coming from the same wavefront. So actually when interference occur between the wavelets or the waves, the secondary waves emerging from the same wavefront, একই wavefront থেকে যখন তোমার একই wavefront থেকে যখন দুটো ওয়েভ সুপারইম্পোজ করে, when the two waves superimpose from the same wavefront, so they give rise to the phenomena of diffraction, which is the nature of that distribution. But preliminary যে ঘটনাটা, the preliminary effect is that you see some light into the shadow region, and that can be explained only by the concept of this wave nature of light. সেটা কিন্তু শুধুমাত্র লাইটের ওয়েভ নেচার থেকেই কিন্তু সেটা এক্সপ্লেন করা যায়। ওকে, is it clear to you? I hope that you have understood. তোমরা নিশ্চয়ই বুঝতে পেরেছো that কি এখানে কি হচ্ছে। So this is what is the wave nature of light that you see over here, which is being explained by this formation of wavefronts, because each point of the wavefront are the source of secondary disturbance. এই ওয়েভফ্রন্টের প্রত্যেকটা পয়েন্ট থেকে কিন্তু কি বেরিয়ে আসবে, from each and every point you will have some secondary waves over here, and it is those secondary waves that enter into the shadow region. এটা হচ্ছে সেই secondary waves গুলোই যেগুলো shadow region এ enter করবে। So this is the motivation of Huygens. So this phenomena was explained on the basis of Huygens principle. তাহলে এই ঘটনাটা Huygens principle থেকে আমরা explain করতে পারবো। Is it clear to you? So this is the reason that why actually Huygens formulated this type of principle. So কেন এটা formulate করেছিল? So now let us write the principle in very details such that we have a proper understanding of it. So একটা heading আমরা এখানে দিয়ে রাখলাম, although I have given it, but still I write it once again as Huygens principle. So according to this principle, suppose if this is a point, you know, এটা একটা point, so from here you will get a spherical wavefront. By this time you have understood that you will get a spherical wavefront over here, so তুমি এখানে একটা spherical wavefront পাবে, and each point of this spherical wavefront is the source of secondary disturbances. তাহলে এইখানকার প্রত্যেকটা পয়েন্ট থেকে from each of the points over here you will get again spheres, এখান থেকে তুমি আবার স্পিয়ার পাবে, from each of these points you will get spheres. The reason behind it is properly known to you. কেন এটা হচ্ছে সেটাও তোমরা জানো, because every point of this wavefront is the source of secondary disturbances. তার মানে Huygens principle এ দুটো জিনিস important. From Huygens principle 2 points are to be studied properly. Number 1, the formation of wavefront, and second, the each point of the wavefront behaves as the source of secondary disturbances. So you should draw circles of uniform nature, otherwise your diagram will not be proper, which is going to be the case in my case. So আমার ক্ষেত্রে তুমি দেখবে যে ডায়াগ্রামটা খুব একটা ভালো হবে না, because I couldn't draw all the circles of uniform size. প্রত্যেকটা সাইজ আমি একই রকম করতে পারিনি। So this is what is I am joining them tangentially. I am joining this tangentially, and this one gives me the secondary wavefront. So I shouldn't use dotted symbols because that will disturb, that will not appear to be proper. So I use a different color, that should be better. And I am joining them tangentially. Try to understand, I am joining them tangentially. Even if they don't look tangential, they are tangential. Tangential যদি দেখে নাও মনে হয় তাহলেও তারা tangential. This one I should use the blue one only. So after a time t, the distance traveled by the waves from here is ct, and this is your primary wavefront. So this one is your primary wavefront. So এটাকে আমরা primary wavefront বলছি. The first wavefront that I consider, that is my primary wavefront, and this black one, this one I call the secondary wavefront. And again the secondary wavefront, all the points will emanate spherical waves, and if you join them you will get the next wavefront. So this is how wavefront after wavefront after wavefront will be formed, and the light will be propagated in the forward direction, এবং এইভাবেই লাইট তোমার ফরওয়ার্ড ডাইরেকশনে প্রপাগেট করতে থাকবে। So let us write, let capital S be a point source, let capital S be a point source, let capital S be a point source of light, be a point source of light in an isotropic homogeneous medium, in an isotropic homogeneous medium. Be a point source of light in an isotropic homogeneous medium, sending out light in all possible direction. sending out light in all possible directions. Sending out light in all possible directions. Stop. So after a time t, we will get a wavefront. So after a time t, we will get a wavefront. So after a time t, we will get a wavefront AB where all the particles have the same phase. We will get a wavefront AB where on the surface of which all the points have same phase. All the points have same phase. On the surface of which all the points have same phase. Actually, AB is drawn by taking S as the center. How do I draw that AB? Actually, excuse me. Actually, AB is drawn by taking S as center, and CT as the radius, is drawn by taking S as the center and CT as the radius. AB is called the primary wavefront. The first wavefront that I draw is called the primary wavefront. AB is called the primary wavefront. Right? That's it. Okay. So next question is that now a very general question arises. That how to construct a wavefront, at any later instant of time, t plus delta t. So delta I will write later on, at a time delta plus. The answer is provided by Huygens, who states that every point of a primary wavefront. So now I start writing. The answer is provided by the Huygens principle. Which states that. So let me write it next. So এখানে আমি Huygens প্রিন্সিপলটা লিখছি। So what is the principle? Every point of the primary wavefront is the source of secondary disturbances. Every point of the primary wavefront is the source of secondary disturbances, which in case of isotropic homogeneous medium, which in the case of isotropic homogeneous medium travels with the speed and frequency, travels with the speed and frequency equal to that of the primary wavefront. So this is very simple, that in case of isotropic homogeneous means everything is same for everybody. So whatever is the speed of the primary wavefront, the same will be the speed of the secondary disturbances emerging from the primary wavefront. So the basic point over here is that you need to construct a wavefront, and every point of this wavefront is the source of the secondary disturbances. তাহলে wavefront তোমাদেরকে বানাতে হবে এবং wavefront-এর প্রত্যেকটা point, every point of the wavefront will behave as a source of the secondary disturbances. Okay, and these secondary disturbances, the speed will be depending upon the nature of the medium. If it is isotropic homogeneous, which is as per your discussion, so everything will appear as the same as that of the primary wavefront. Okay, so this is what happens. So the next point that I come over here, so next point that I am going. So let us come to the next point now. So we consider the points P1, P2, P3 on the primary wavefront. So what are my P1, P2, P3? So these are my P1, P2, P3, which I should mention. This one is P1, this one is P2, this one is P3. So these are the points P1, P2, this point is P3, and so on, right? So P1, P2, P3 are these dots. So it's better that I P1, P2, P3, dot, dot, dot. These dots. So these dots are the P1, P2, P3, and so on. You just put dots over all of them, even প্রত্যেকটাতেই dot দিয়ে দাও. So P1, P2, P3 like this. Okay. So পরপর চলছে. So okay, now come back to the discussion. এখানে আমরা বলছি we consider the points P1, P2, P3, dot, 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 dot on the primary wavefront. We consider the points P1, P2, P3 on the primary wavefront. According to Huygens principle, these points are the sources of secondary disturbances. Taito, according to Huygens principle, these points are the sources of wavelets. Wavelets means, you know that what is wavelet, right? Wavelet means small waves. Small waves are called wavelets. ঠিক আছে? Wavelets মানে বাচ্চা wave. Small waves, baby waves are called wavelets. According to Huygens principle, these points are the sources of wavelets or secondary disturbances. So taking these points as the center, so taking these points as the center, এই পয়েন্টগুলোকে সেন্টার ধরছি, taking these points as the center and C delta t. C delta t is the distance traveled within a time interval of delta t, and C delta t as the radius, we draw spheres. আমরা spheres draw করছি, we draw spheres. The sections of this sphere by the planes are circled, because in the board uses circles. The sections of these spheres by the plane of the paper, wherever I am drawing, because you see that in your diagram you don't see sphere. তুমি তো sphere দেখছো না, তুমি circle দেখছো, because you are drawing on a plane. So that is what I am writing. The section of these spheres by the plane of the paper are circles, as in figure. হয়ে গেল, as in figure. I have done it. We join these circles tangentially by dotted lines. We join these spheres tangentially. Spheres to na circles bolechi. We join these circles tangentially. And this gives bracket আমি লিখছি black line, this black one. In your exam you may use dotted line if you don't have different colors, which is very rare for you. So then you can use the dotted symbol. You will write dotted line, and this dotted line, I write this black line, gives the position of the wavefront after a time. This gives the position of the wavefront after a time t plus delta t. After a time t plus delta t. After a time t plus delta t. And this is known as the secondary, এটাকে আমরা বলে থাকি secondary wavefront. So this is called the secondary wavefront. So I have tried to explain you in a proper manner. আমি proper manner explain করতে চাইলাম. I have tried to explain it in a proper manner, and also at the same time I have provided a note to you such that you can get help at the time of examination. But I recommend once again, don't copy everything as I have provided to you. Although this is a proper note for examination, I used to write it during my time. So আমিও হলে এরকমই লিখতাম, but I request all of you so not to copy, so then it will be same for everybody of you. অনেকের ক্ষেত্রেই same হয়ে যাবে, and that will create a bad impression to the examiner. So you should have something of your own independence. So তোমার নিজের কিছু থাকা উচিত. So take help from the book, take help from these notes, and try to make it as much independent as possible. Okay, so this is all about the Huygens principle. So I just recapitulate once more that this is a point source of light. So after a time t, the waves that emanate from here, so all of them will travel a distance of ct, right, like this, and this actually gives you a sphere as shown by this blue line. This is called the primary wavefront, where the phases of all the points are the same because all the points has been generated by the same radius, that is ct. So this is the spherical wavefront. I don't see a sphere because it is a two-dimensional board, so we just get a part of a circle. Now every point of this blue line is the source of secondary disturbances. So that is what is the important point from Huygens, that every point on this blue line are the source of secondary disturbances. Okay, and that is why you taking these points as the center, what will be the distance traveled in a time of further time delta t? So delta t time কতটা distance travel করবে? Definitely it will travel a distance of c delta t. So that is what I am trying to provide you over here. So it will travel a distance of c delta t. So c delta t distances are traveled. So এখান থেকে দেখো c delta t, all of them travel c delta t distance. So that is why once again taking this as the center, I draw spheres of radius c delta t. So that is what I have written, taking these points as center and c delta t, we draw spheres, sections of the spheres of circle, and we join these circles. You see that all of the points on this circle are again on same face because they are generated by the same radius of c delta t. So if you join all these points tangentially, so then we see over here this, and this gives black line the position, and this gives the position of the wavefront after a time t plus delta t. So this is the blue is the wavefront at time t, and the black is after a time t plus delta t, and this is called the secondary wavefront. And this way the tertiary wavefront, and then the next and the next wavefront goes on, and that is how you get the entire system of propagation of light. Now one of the drawback of the Huygens principle, although it is a beautiful concept that has explained all the phenomena related to wave optics, so সমস্ত কিছু এখানে explain করা যেতে পারে, there is a difficulty over here, that is you see that there is a chance of backward propagation also, because if this is the point, so then it can propagate in this way, and as the sphere is also on this side, sphere একটা surface এইদিকেও আছে, so there is a probability of backward transmission also, but that actually doesn't happen in practice. That is, you hold a torchlight and the light is coming out in the backward direction. তুমি একটা torchlight সামনের দিকে দিচ্ছ দেওয়ালের মধ্যে in the frontal wall, but you see some light on the backward wall. So that is being predicted by this theory, because if this is the wavefront, so এটা যদি wavefront হয়, if this is the wavefront, so Huygens কি বলছে, every point is the source of secondary disturbances. So secondary disturbances come out in the forward and the backward, both directions it can come out, but you see that there is no backward light, the light goes only in the forward direction. So this has been avoided by some advanced theory which is called the Fresnel-Kirchhoff theory. So above the Huygens theory opore Fresnel and Kirchhoff, two physicists, so they have worked upon and provided a convincing theory with the help of which you can avoid the backward propagation. The backward propagation can be avoided, but that theory couldn't be discussed right now over here, so it is the beyond the scope of our discussion, so we will just mention it. খালি আমরা mention করে দিলাম that backward propagation cannot happen, and this can be explained with the help of some advanced theory which is called the Fresnel-Kirchhoff theory, which is beyond the scope of our discussion, and hence we will not go to it. So this is all about the Huygens principle and the concepts of wavefront. I hope that you have understood it. And now, depending upon this Huygens principle, we may discuss other phenomena such as the interference of light. আমরা interference of light এখান থেকে explain করতে পারি. We can explain interference, we can explain the diffraction of light. So these two are in your course in this particular paper and semester, the interference and diffraction of light. And in your another semester you will have the polarization of light. So polarization can also be explained on the wave theory. You have the entire electromagnetic theory. There you will learn other concepts of light. So till then, it's fine up to the Huygens principle. So let us wind up for the Huygens principle over here. So there are some applications, so that you will see as per time progresses, you will see the different applications of Huygens principle. So thank you. Hello dear students. Today in this class, I will be discussing about the interference of light, one of the topics in your paper CC4 of this particular semester. I hope that you have studied something about interference of light. বাংলায় এটাকে আমরা আলোকের ব্যতিচার বলেছিলাম. In your higher secondary classes, you have some ideas definitely regarding the interference of light, that what is actually going on. Definitely here we will study some advanced issues. Very advanced issues will be studied over here. And then we will slowly, after gathering information about the interference of light, we will slowly move on to the diffraction of light, another interesting phenomena that is being shown by the light waves actually. So in these aspects, the light will be definitely considered as a wave. So it is a wave property of light. As you know that in the previous topics of this particular paper was pertaining to waves only. That was basically about the sound waves. And in this discussion, we will be discussing about the light waves. So as I was saying that I will be discussing about the interference of light. আমি বলছিলাম যে আমি interference of light এখানে discuss করব. Okay, so let us start the discussion. Before I start the discussion, I need to understand one of the interesting phenomena that is called the coherence. So our interference discussion করার আগে আমাদেরকে coherence ব্যাপারটা একটু বুঝে নিতে হবে. I will show you or teach you coherence in details later on. Coherence সম্পর্কে আমি পরে তোমাদেরকে বলবো. No need to write anything at this present moment. Present moment you just listen it carefully such that the understanding is developed, and later on we will provide a good discussion or a good note related to this coherence. So আপাতত কিছু লেখার দরকার নেই, nothing to write, just to listen carefully. So this is one of the important condition that is to be obeyed by the interfering signals. So interference মানে তুমি বুঝতেই পারছো, দুজন তোমার লাগবে. So minimum you need two entities, you need two waves. So the two waves will superimpose on one another. একটা ওয়েভ আরেকটার উপরে পড়বে, traveling in the same direction. That is what is known as the interference of light, and it will give rise to some resultant phenomena. এবং আমরা কিছু resultant effect কিছু দেখতে পাবো. We will see some resultant effect. That is what is the interference of light. Now in order to have interference, to study interference, you need coherent sources. Interference করার জন্য আমাদের coherent source এর খুব বেশি দরকার. We need coherent sources. Now the question is, what is a coherent source? Coherent source বলতে আমরা কি বুঝি? What do we understand by coherent source? So coherent source means you have to take two source of light. So এরকম দুটো source আছে. Now whether these two source is coherent or not. If it is not coherent, then interference cannot be seen at the output. যদি এরা coherent না হয় তাহলে তুমি বাইরে interference দেখতে পাবে না. So the expected effect will not be visible at the output. If they are incoherent sources, then the expected output will not be visible on the screen. So সেটা দেখা যাবে না. So coherent ব্যাপারটা কি? What is coherence? Coherence means that either the phase difference of this between these two signals, এখান থেকে একটা wave আসে, so there is a wave from here, right? And there is a wave from here also. Wait, এখান থেকে একটা wave যাচ্ছে, and there is a wave from here also, right? So these are my two coherent waves. এই দুটো হচ্ছে আমার coherent waves আমাদের কাছে আছে. These are my two coherent waves, right? So not coherent waves, sorry. Suppose these two signals are coherent signals. So by coherent signals we mean that coherence কাদের মধ্যে হয়? Coherence is between the two signals, the two source of light. So that means that the phase difference between these two is identical and it is constant all throughout. এই দুটো সোর্সের মধ্যে যে phase difference, I hope that by this time you also understand what is phase and what is the phase difference. You have learned it in the classes of waves, the preliminary waves that you have learned the concept of waves. I mean concept of waves very details. In the very details I have shown you that how a progressive wave develops. So there you know that phi or the phase actually represents the state of vibration at that particular instant. So কোনো একটা instant যে state of vibration, the state of vibration is given by that phi. The state of vibration at any instant or at any position, so that is what we call the wave. So sorry, that is what we call the phase of that particular wave. And what is the phase difference? So phase difference is the difference of the activity between these two signals. So এই দুটো সিগন্যালের মধ্যে যে ডিফারেন্স আছে সেটাকে আমরা phase difference বলছি. In your classes of electricity you may have gone through. So electricity classes, in the AC signals particularly, you have the application of this phase difference. The current and voltage either they lag or they lead by a constant phase. So এখানে যে ডিফারেন্সটা, the difference between the two signal, that must be always constant. So if I say that the phase difference is pi by 4, so pi by 4 should be the phase difference at all instant of time. So যেই টাইমেই করো না কেন, at t equal to 0 second or at t equals to 10 minutes or at t equals to 1 hour, so whatever will be the issue, so issueটা যাই হোক না কেন, whatever be the issue, this phase difference should always be pi by 4. Then I will call the two sources to be coherent. The phase difference can be 0 also, that is both the sources are at same phase, but that is an ideal. So that is a special case. That is a special case. So এদের দুজনের মধ্যে আমরা সবসময় এক্সপেক্ট করি একটা ফেজ ডিফারেন্স থাকবে, এন্ড সেই ফেজ ডিফারেন্সটা কি হতে হবে? কনস্ট্যান্ট হতে হবে। দ্যাট ফেজ ডিফারেন্স শুড বি কনস্ট্যান্ট। 0 is a particular number. So 0 মানে কি? এরা দুজনেই তার মানে সেম ফেজে ছিল। Both of them are in the same phase. Same phase means the maxima of both of them occurs simultaneously, the minima occurs simultaneously. What do you mean by two waves in same phase? Suppose this is a wave. So if another wave is in same phase, so then I will call it to be like this. So this is, so the black and the red are definitely in same phase because the maxima of them occurs at same point, the 0 of them occurs simultaneously and the minima of them also occurs simultaneously. Suppose this is the time t. So whatever be the time, their maxima, minima, 0 all occurs simultaneously. So that is what I call a coherent. That is what I call that they are in same phase. Same phase থাকলে তাদের মধ্যে phase difference কত? What is the phase difference? So that is, the phase difference is 0 and that is also a particular special case of coherence. আবার এরকমও হতে পারে এদের মধ্যে একটা pi by 2 phase difference আছে, so বা pi phase difference আছে, ধরে নাও এদের মধ্যে pi phase difference আছে, there is a pi phase difference between the two waves. So what do you mean by pi phase difference between the two waves? দুজনের মধ্যে pi phase difference আছে মানে ধরো এটা একটা wave, so this is a wave, so pi phase difference means, so this one, so pi, ঠিক করলাম? No, it is not proper. pi by 2 করে দেখানো যাক। সো পাই আমরা দেখে নিচ্ছি। সো pi by 2, so what do you mean by pi by 2? So pi by 2 means, so how much distance is pi by 2? কতটা ডিসটেন্স আমাদের এখানে pi by 2 আছে? পাইটা ঠিকই ছিল, pi was correct, there was no problem in pi. একজন যখন ম্যাক্সিমা ছিল তখন আরেকজনের মিনিমা ছিল, so pi was correct, so that one was the phase difference of pi. So what is the phase difference of pi by 2? So pi by 2 phase difference মানে হচ্ছে এরকম হবে, so that one is the pi by 2, so that one will be এই যে আমি যেটা ড্র করছি, whatever I am trying to draw at this instant, so that one is the pi by 2 phase difference. So এটা হচ্ছে এদের pi by 2 phase difference, right? So এইটার 0টা এখানে হয়েছে, but এইটার 0টা pi by 2 পরে হয়েছে, the 0 is after the interval of pi by 2 because this time is pi by 2, এই টাইমটা হচ্ছে pi by 2, right? So এইটার যখন 0 হয়েছে, when this is 0, so then it has attained a minimum point and so on. So এইভাবে তুমি pi by 2 phase difference তুমি বলতে পারো, so that is how you have a pi by 2 phase difference between the two waves. So whatever I mean to say over here, so আমি এখানে যেটা বেশি করে বলতে চাইছি সেটা হচ্ছে দুটো যে সিগন্যাল আছে, you have two signals. Now come back to the only this issue. These are the two signals of light. This one I called S1 and this one I called S2. So the phase difference between S1 and S2 should be constant always. যদি এদের মধ্যে phase differenceটা সব সময় constant হয় তাহলেই সেই দুটোকে আমি coherent source বলবো। আর coherence is a necessary condition for interference. Coherent যদি না হয়, if the sources are not coherent, so then interference will not take place, right? That's it about coherence. এই যে কথাটা বললাম, the last statement that I made, that without coherence interference will not occur, that is what I will discuss as and when required. So যখন সময় আসবে সেটা ডিসকাস করে দেবো। I will definitely discuss with you that why coherence is important, because this must be a question in your mind. তো তোমার এটা একটা কোয়েশ্চেন আসা উচিত যে স্যার কেন কোহারেন্স রিকোয়ার্ড, সো why coherence is necessary. So I will definitely discuss it with you. তো সেটা আমি তোমাদের সাথে নিশ্চয়ই আলোচনা করব। সো দেখা যাক, সো লেট আস সি হোয়াট ইজ অ্যাকচুয়ালি গোইং অন। দেখা যাক। So I write the definition of interference: when two or more sources sets of waves coming from coherent sources of nearly equal amplitude, when two or more sets of waves coming from coherent sources of nearly equal amplitude and equal wavelength, so wavelength must be equal but amplitude may not be equal, nearly equal wavelength, propagating in the same direction, so not in opposite direction, same direction e hote hobe, so they should propagate in the same direction, and wavelength propagating in the same direction, superimpose on one another, then what happens at the output? Then alternate dark and bright fringes, একটা dark একটা bright, so then alternate dark and bright fringes are noticed on a screen. Then alternate dark and bright fringes are noticed on a screen. This phenomena of modification in the distribution of light intensities, in the region of superposition of the wave, is called interference. এটাকে আমরা ইন্টারফারেন্স বলে থাকি। When two or more sets of waves coming from coherent sources of nearly equal amplitude and wavelength propagating in the same direction superimpose on one another, then alternate dark and bright fringes are noticed on a screen. This phenomena of modification in the distribution of light intensities in the region of superposition of the waves is called interference. এই ঘটনাকেই আমরা ইন্টারফারেন্স বলে থাকি, is called interference. Okay, so you see that I call that there are two sources of light and they two interfere. তারা ইন্টারফেয়ার করছে এই জায়গাটায়, so এইটা ওয়েভ ইন্টারফেয়ার করছে, waves are coming out in all directions, so there can be another interference. এখানে আরেকটা ইন্টারফারেন্স হতে পারে, and suppose there is a screen, এখানে ধরো একটা স্ক্রিন আছে, there is another interference over here, এখানেও একটা ইন্টারফারেন্স হচ্ছে, so there are the interference between the light waves coming from these sources. এই সোর্স গুলো থেকে ওয়েভস বের হচ্ছে, from these sources waves are coming out and they interfere at different points on the screen. এবার স্ক্রিনের প্রত্যেকটা জায়গায় কি লাইটের ইন্টেন্সিটি একই রকম হবে? Will the light intensity be same at all the points of the screen? So definitely the answer is no. There is a variation in the intensity of light. So what is the reason of that? So সেটার কারণটা কি? So here from started the discussion of interference. So people near about 300-400 years ago noticed this phenomena, and that is why started the discussion of interference. তাহলে কি দেখা গেল? দুটো সোর্স অফ লাইট যদি কোহারেন্ট থাকে, if two sources of light are coherent and then you hold a screen, তুমি একটা স্ক্রিন ধরেছো, তাহলে দেখা যাচ্ছে it is seen that on the screen the light is not uniform all throughout. You see that if you just hold a torch in front of a wall, you just throw some torch light on a wall, তুমি কিছু টর্চ লাইট তুমি দেওয়ালের মধ্যে দিচ্ছ, তাহলে দেওয়ালটাতে কি হবে, what will happen on the wall? At least at the central position you will see that the light intensity is uniform. অনেকটা জায়গায় জুড়ে তুমি দেখবে লাইটের ইন্টেন্সিটিটা ইউনিফর্ম আছে, it is uniform all throughout. But whenever you take two sources of light, not two torchlight, দুটো torchlight দিয়ে কিন্তু interference হবে না. Interference will not occur with two torchlights because two torchlights are never coherent. I will be discussing about this in details in some other classes. Let us start today the discussion. Let me show you that what is the problem if the two sources are not coherent. Coherent না হলে কি সমস্যা আছে সেগুলো দেখাই আগে, then I will show you that what is actually going on. So if you just hold two torchlights on a screen which are not coherent, দুটো টর্চ লাইট মারছো যারা কোহারেন্ট নয়, তাহলে তুমি দেখতে পাবে স্ক্রিনে কিন্তু ইউনিফর্ম ইন্টেন্সিটি আছে। অন দ্য স্ক্রিন দেয়ার ইজ ইউনিফর্ম ইন্টেন্সিটি, দেয়ার ইজ নো ভ্যারিয়েশন। But at the same time, when you hold two coherent sources towards the screen, you see that there is a modification in the distribution of light intensities. মানে incident intensity and output intensity after superimpose করার পরে একটা intensity variation স্ক্রিনে দেখা যাবে। On the screen you will see that there is a variation in the intensity of light. মানে কোথাও দেখতে পাবে লাইটটা খুব ডার্ক, মানে অন্ধকার, you see there is dark, and at some points you see it is very bright, that is full of light. কোনো জায়গাতে ভর্তি আলো দেখতে পাবে, that is bright, very much bright, and at few points you will see that those are dark. কিছু পয়েন্টে দেখতে পাবে তারা dark আছে, right? A few points is dark and a few points is very bright. So that is what you will see. Now the question is, what is the reason of it? কেন এই ঘটনা ঘটছে? So there should be some associated theory, there should be some baseline, there should be some reference which will be able to describe this phenomena. So এই যে phenomena যেটা তুমি দেখতে পাচ্ছ তার তো একটা প্রপার থিওরি থাকবে, there should be some underlying theory of these effects. That is what we are going to study in these classes. এই ব্যাপারগুলোই আমরা আজকের এই ক্লাসে শেখার চেষ্টা করব। আজকের ক্লাসে নয়, it will take 5 to 6 to 8 classes, at least 6 classes I believe it will take to discuss, because many things have to be discussed over here. That also depends on how long will be the class. So that definitely I believe 5 to 6 classes will be required to complete these effects in a proper manner. Proper manner যদি শিখতে হয়, so it will take some time. So let us start the discussion, and I hope that towards the end of the discussion you will definitely understand, or you will develop a concept regarding the interference of light, that what actually interference is. First of all, whatever we will discuss is the constructive interference. আমরা প্রথম যেটা আলোচনা করব সেটা হচ্ছে কনস্ট্রাকটিভ ইন্টারফিয়ারেন্স। What is constructive interference? We are going to discuss constructive, বাংলায় পড়েছো গঠনমূলক ব্যতিচাপ, মোস্ট প্রবাবলি হয়তো তাই বলতো, আর ধ্বংসাত্মক ব্যতিচাপ, that is destructive interference. Constructive means there you will get more intensity. More, এখানে তুমি বেশি ইন্টেন্সিটি পাবে, here you will have more intensity, and destructive means here you will get less than the expectation. মানে দুজনের সাম করে যা হওয়া উচিত সেটা মানে that. So you will not get uniform, so it will be a distribution. Somewhere you will get more, somewhere you will get less. Okay, so what is a constructive interference? If the two waves meet in phase, phase মানে তুমি জানো, you know what is phase. If the two waves meet in phase, comma, then what will happen? Definitely the amplitude will be greater. So যখন same phase meet করে তখন amplitudeটা কি হবে? Amplitudeটা বেশি হয় সেই জায়গাটা। When the two waves meet in phase, then the resultant amplitude কি হবে? Then the resultant amplitude is maximum. When the two waves meet in phase, then the resultant amplitude is maximum. That means that is bright fringes are formed. সেই জায়গাগুলোতেই ব্রাইট তৈরি হবে, that is bright fringes are formed. Okay, that is bright fringes are formed, and it is known as constructive interference, এটাকে constructive interference বলা হয়। Got the idea? Fine, fantastic. Now go for the destructive interference. এবার destructive interference এ চলে আসো, ধ্বংসাত্মক ব্যতিচার। destructive interference মানে যেখানে দুটো ওয়েভ অপোজিট ফেজে মিট করে, destructive interference. Once I develop the mathematical theory, you will understand everything up to the mark, and there will be completely clear concept available to you. Okay, so এখানে আমরা লিখব if the two waves I will just copy it and then I will make some changes. If the two waves meet in opposite phase, if the two waves meet in opposite, if the two waves meet in opposite phase, then the resultant amplitude is minimum. That is dark fringes. That is, dark fringes are formed and it is known as destructive. And it is known as destructive interference. That's it. If the two waves meet in opposite phase, then the resultant amplitude is minimum. That is, dark fringes are formed and it is known as destructive interference. এবং এটাকে আমরা destructive interference বলে থাকি, right? So you see that whenever, তার মানে আমি যদি summarize করি, if I summarize that you need two lights which are coherent in nature, তোমার কাছে দুটো লাইট সিগন্যাল লাগবে যারা কোহারেন্ট আছে, মানে the phase difference between them is constant, and when they meet at different points, তারা যখন different points এ meet করে, they can meet in same phase or they can meet in opposite phase. So if they meet on same phase, then you will see that the intensity is higher on that points, and if they meet on opposite phase, so then you will see that the intensity is lesser at those points. Those are the dark points. So that is why you get the bright points and the dark points, and you get the constructive and the destructive interfering points. So that is all about this discussion, and let us now go into the formal theory of interference. এবার আমরা এর যে formal theory-টা আছে, so let us try to go across that. Mathematical theory of interference. Mathematical theory of interference. So you need two sources. তোমার দুটো source লাগবে. So দেখা যাক two source. How do I take the two sources? Okay, so this is the basic diagram that we need for our discussion. So you see that whatever I have done is that this capital S is my original source, and this capital S, light from this source capital S is allowed to fall on these two slits. এই দুটোকে আমি slits বা holes আমি বলছি ছিদ্র. So these are fine holes over here. So very fine holes are dropped over here. So এখানেতে ছিদ্র করা হলো. So I drop some holes over here. Now what is the purpose of these holes? এই holes গুলো কি করবে? So the purpose of these holes is that, so এই holes এর purpose হচ্ছে তারা কি করবে? What will they do? So they will just লাইট ফ্রম হিয়ার এখানে এরকম ভাবে আসবে, আর এখান থেকে লাইটটা এখানে পড়বে। নাও আই সে দ্যাট দিস S1 and S2 আর কোহারেন্ট ইন নেচার। আমি বলছি S1 আর S2 এরা নাকি কোহারেন্ট হবে। দিস S1 and S2 আর কোহারেন্ট ইন নেচার। হোয়াই ডু আই কল ইট কোহারেন্ট? সো কেন আমি এটাকে কোহারেন্ট বলছি? এট দ্য বিগিনিং দ্য ফেজ ওয়াজ 0, সো এখানে ফেজটা 0 ছিল। এইবার এইটা ধরো একটা ডিস্টেন্স ট্রাভেল করলো, দিস ট্রাভেল সাম ডিস্টেন্স d1 এন্ড দিস ওয়ান ট্রাভেলস আ ডিস্টেন্স d2। এইটা একটা d1 ডিস্টেন্স ট্রাভেল করলো, এটা একটা d2 ডিস্টেন্স ট্রাভেল করলো। সো হোয়াট ইজ দ্য ফেজ এট দিস পয়েন্ট S1? S1 পয়েন্টে ফেজটা কত হবে? সো ইউ নো দ্যাট দ্য ফেজ ইজ গিভেন বাই 2 পাই বাই ল্যামডা ইনটু পাথ ডিফারেন্স। সো এখানে কত ডিস্টেন্স গেছে? সো দ্য ডিস্টেন্স ট্রাভেলড ইজ d1। সো এটার রেসপেক্টে দ্য ফেজ অফ দিস ওয়ান ইজ phi1 is 2 pi by lambda d1. And what is the phase of this point S2 with respect to this S? So that will be, এটার ফেজ হয়ে যাবে হচ্ছে 2 pi by lambda into this distance. এই জানো তো এই ফর্মুলা, ফেজ ডিফারেন্স is 2 pi by lambda into path difference. So with respect to the point S, the phase of S1 is 2 pi by lambda d1 and the phase of S2 is 2 pi by lambda d2. So these are the two phases. So what is the phase difference between the 2 points S1 and S2? তাহলে S1 আর S2 এর মধ্যে ফেজ ডিফারেন্সটা কত হবে? So the phase difference between S1 and S2, that is some phi1 minus phi2. So that will be simply 2 pi by lambda multiplied by d1 minus d2. তাহলে এটা হবে হচ্ছে phase difference between the 2 points S1 and S2, and this phase difference is definitely a constant. এবং এই phase differenceটা definitely constant আসবে because d1 d2 is constant. Did you get the point? So আমার পয়েন্টটা বুঝেছো? তার মানে what happens is that S1 and S2 behaves as coherent sources. তার মানে S1 আর S2 কিন্তু এখন কোহারেন্ট হিসাবে বিহেভ করবে। S1 and S2 will behave as coherent sources. You see that if the idea is clear or not, ভালো করে দেখো আইডিয়াটা বোঝা গেল কি গেল, রাইট? phi1 phi2 ফেজ গুলো আগে বের করো with respect to the point S, then you take the difference of them. So it is the phase difference between S1 and S2. তাহলে S1 আর S2 এর মধ্যে ফেজ ডিফারেন্সটা দেখা যাচ্ছে কি হচ্ছে? The phase difference between S1 and S2 is constant in nature. The phase difference between S1 and S2 is constant in nature. Is constant in nature. Got it? তাহলে এই ফেজ ডিফারেন্সটা কনস্ট্যান্ট হয়ে যাবে, এটা কনস্ট্যান্ট ফেজ ডিফারেন্স আসবে, বুঝতে পেরেছো? এন্ড কনস্ট্যান্ট ফেজ ডিফারেন্স ইজ নিডেড ফর মাই ইন্টারফারেন্স এফেক্ট। এইবার কোয়েশ্চেন, নাও দ্য কোয়েশ্চেন দ্যাট হোয়াই ডু আই টেক দ্য কোহারেন্ট সোর্সেস ইন দিস ওয়ে? এরকম স্লিট বানিয়ে কেন আমি সোর্স নিলাম? That is what is needed to be answered. You see that this will take some time. So এইগুলো কিন্তু টাইম নেবে, it will take a lengthier time to complete the syllabus. But this will help you to develop a proper physical concept which is not available in the textbook. Textbook তো এটা বলা থাকবে, it will not be provided on the textbook that why do you take the slits in this way? এইভাবে তুমি কেন একটা সোর্স থেকে দুটো সোর্সে ভাগ করে নিলে? Why do you take coherent source in this mechanism? The reason behind it is that suppose you take two independent sources like this, এটা একটা নিলে, two candles, পড়েছো হয়তো হায়ার সেকেন্ডারিতে, that you cannot produce interference with two candles. The simple reason of it is that the two candles are incoherent in nature. দুটো ক্যান্ডেল কখনোই কোহারেন্ট হতে পারে না। Two candles can never be coherent. They are incoherent in nature. Why do you call them incoherent and why these sources are called coherent? কেন এই সোর্স দুটো কোহারেন্ট? এখানেও তো এই দুটোর মধ্যে তো ডিসটেন্স কনস্ট্যান্ট। The distance between these two is constant between these two. They are not coherent in nature. But this, the arrangement that I had made, আমি যে অ্যারেঞ্জমেন্ট এখানে করে দিয়েছি সেই অ্যারেঞ্জমেন্টটা কিন্তু coherent in nature. Why? কেন? আনসার আছে, I will provide you. Suppose একটু হাওয়া বয়ে গেল, উইন্ড পাসেস, এখান থেকে হাওয়া যাচ্ছে, উইন্ড পাসেস, রাইট? সাম এয়ার ফ্লো অফ এয়ার অকার্স ওভার হিয়ার, সো ডেফিনেটলি দ্য স্টেট অফ ভাইব্রেশন উইল বি ডিস্টার্ব। তাহলে যে লাইটটা ছিল সেটা একটু ডিস্টার্ব হয়ে যাবে। ধরো ক্যান্ডেল ধরেছো তুমি, ইউ হ্যাভ হোল্ড আ ক্যান্ডেল, সো ক্যান্ডেলের ভাইব্রেশনটা একটু ডিস্টার্ব হবেই যদি হাওয়া যায় ওখান দিয়ে, রাইট? সো definitely the candle will be disturbed some way. বা ধরো you are holding the candle and you are slightly displaced, ধরো তুমি একটু নড়ে গেলে, you are displaced, or the source itself is displayed. So there are many sources of this type of disturbances to occur in the source. সোর্সের মধ্যে ধরো একটা ডিস্টারবেন্স চলে আসলো, তুমি বুঝলে ডিস্টারবেন্স আসলো সোর্সের মধ্যে। তাহলে এই যে ডিস্টারবেন্স আসলো, ধরো এখানে, ধরো এটা একটু x পরিমাণ সরেই গেল, suppose that this source is displaced by an amount x, right? So some disturbance is produced in this. তাহলে কি হবে? সেই ডিস্টারবেন্সটাও কি হবে? এই দুটোর মধ্যেই প্রপাগেট হবে। The disturbance will be propagated in both of them. Are you getting it? কোনোভাবে ডিস্টারবেন্স হলো, ডিস্টারবেন্সের অনেক সোর্স হতে পারে, there are different sources of disturbances. The wind blows, একটু হাওয়া চলে গেল, the source vibrates, source টা একটু নড়ে গেল, the source vibrates or displaced in the position. So there are many sources of disturbances produced on the source. So যখনই এখানে একটা error আসলো, there is some disturbance, the same disturbance will be propagated to phi 1 and to phi 2. এই same disturbance কিন্তু phi 1 এবং phi 2 দুইজনের মধ্যেই আসলো, এই যে প্লাস x হলো তো। কিন্তু যখন তুমি ডিফারেন্স নিচ্ছ, লুক এট দ্য বিউটি। সো এবার দেখো বিউটিটা, তুমি যখনই ডিফারেন্স নিচ্ছ, as you are taking the difference, the disturbance cancels out. দুটো ডিস্টারবেন্সই কিন্তু দেখো ক্যান্সেল হয়ে যাচ্ছে, both the disturbance over here cancels out. That means what? So this phi always remains constant independent of time. এই যে কনস্ট্যান্ট কেন বলেছি এটাকে, why do I call it constant? Even if some disturbance is provided, even if some disturbance occurs to the source, the disturbance is equally propagated in both of them. Disturbance টা দুইজনের মধ্যেই একই রকম ভাবে propagate করছে, the disturbance is propagated in an equivalent amount in both of them such that the disturbance get cancelled from both the sources and you are left with a constant factor of d1 minus d2. এবং তোমার কাছে কি থাকে, you have a constant factor d1 minus d2. So that is how we call it coherent source. এই জন্য আমরা এদেরকে বলি কোহারেন্ট সোর্স, রাইট? এভাবে আমরা কোহারেন্স আমরা নিই। এইবার দুটো ক্যান্ডেল, দ্য টু ক্যান্ডেলস, এইচএস এর বইয়ে লেখা থাকতো, ইন ইউর হায়ার সেকেন্ডারি বুকস ইট ইজ রিটেন দ্যাট দে ক্যানট প্রডিউস কোহারেন্স। নাও দ্য রিজন হোয়াই দে ক্যানট প্রডিউস কোহারেন্স, রাইট? সো দিস আর মাই টু সোর্সেস, এই দুটো হচ্ছে আমার সোর্স। এইবার এখানে একটু নড়ে গেল, দিস সোর্স ইজ স্লাইটলি ডিস্টার্ব at any moment, but this one is not disturbed. এইটা ডিস্টার্ব হলো বাট এইটা ডিস্টার্ব হলো না। So the phase difference is now phi 1. Now after sometimes suppose some additional disturbance is produced in this one. এইটাতে disturbance আসলো but এইটাতে আসলো না। There is no disturbance in this one but there is some disturbance over this one. So definitely the phi 1 will be changed to some phi 2. Phase difference তো চেঞ্জ হয়ে যাবে, কেননা দুইজনেতে ইকুয়াল চেঞ্জ আসেনি। Equal change did not occur in both of them. কোনোদিনও আসতেই পারে না। So equal change cannot occur in both of them. হ্যাঁ, যদি আসে, if it comes then it will be coherent. I have no obligation over that. But in general the disturbance may not be same. ধরো এইখানে একজন এসে ফু দিয়ে চলে গেল, a person comes and blows some air over here but the same is not done here. এখানে করা হলো না, the same is not done here. So definitely the phase will change because the state of vibration of this one will change due to the blow of air, but over here it doesn't change. After 5 minutes somebody comes here and blows some air, এখানে এসে একজন ফু দিয়ে চলে গেল, so again the phase difference changes, right? But এখানে যদি কেউ হাওয়া দেয়, if somebody blows some air over here, the same disturbance in the form of x, the same disturbance in the form of x will be propagated to both. দুইজনের মধ্যেই একই ডিস্টারবেন্স যাবে and they will mutually be cancelled. In physics you will see that in many number of times these type of things are done to get the things nullified, to get the things cancelled in nature. I can provide you a beautiful example of the same. Have you ever done any experiment on meter bridge? If you have not done in your school, then your school and your teachers have not done justice to you. যদি তুমি মিটার ব্রিজের কোনো এক্সপেরিমেন্ট করে না থাকো, তোমার মাস্টারমশাই এবং তোমার স্কুল তোমার সাথে অন্যায় করেছে যে তোমাকে করানো হয়নি, রাইট? সো আই ডোন্ট নো ইফ ইউ হ্যাভ ডান ইট অর নট। ইফ ইউ হ্যাভ ডান ইট, সো দেন ইউ হ্যাভ necessarily have done this meter bridge experiment in electricity. In electricity, sometimes we call a measurement which is called a direct current. আমরা এক ধরনের একটা মেজারমেন্ট নিই যেটাকে বলে which is called the direct current measurement, and another measurement is called the reverse current measurement. Why this is done in the meter bridge? Because in the meter bridge some errors are there. Meter bridge এর মধ্যে কিছু errors থাকে, there is some error in the meter bridge on the ends এ কিছু error থাকে meter bridge. I am not going into the details of it, you will learn in the practical classes of electricity. Maybe you are using meter bridge in your laboratory classes in this semester also, because there is a practical on Carey-Foster's bridge, and in Carey-Foster's bridge, and even once again, if your colleges are not teaching you the experiment on meter bridges, so your colleges are not doing justice to you, because it is in the course and it is an important experiment and you should go through it. এবং সেটা তোমার অবশ্যই শেখা উচিত সেখানে, right? I don't know that if you are learning it or not, so hopefully you are doing so. So এখানে তুমি suppose this is the, there is two measurements, one is direct current measurement, one is reverse current measurement. Direct current means the current is allowed to pass in this direction in once, and another time that current is allowed to pass in this direction, and you measure some length in either of the situation. Now the question, and you take the mean, so you write that the actual measurement, so the actual measurement is the direct current measurement plus reverse current measurement by 2. Now the question is why this is done. এটা কেন করা হয়ে থাকে? Why do people actually measure once in direct current and once in reverse current? The reason is, suppose you measure some length in the direct current to be L plus X. L is the actual length, L টা হচ্ছে actual length, but whatever I measure is L1. Actual length is L, but I measure L plus X. Why? Because of the error present in the system. System এ যেহেতু error আছে সেজন্য আমি L plus X measure করি। And then while in the reverse current, I measure it to be L minus X, because once the error will be added up and once the error will be subtracted. That is the internal mechanism of the meter bridge, which I am not going into the details right now. এখন সেটা বলা সম্ভব না, because this is the class of optics. I am discussing something else. If I get some time, or if it is your requirement, if it is your demand, so then I can discuss on some other classes. If you want, then I can do it. So suppose L is the actual length, so due to the presence of X amount of error, it comes out to be L plus X. And when you reverse the direction of the current, so then it comes out to be L minus X. And now you see that why do you take the average? That is L1 plus L2 by 2. Because once you take L1 plus L2 by 2, you get actually the correct value. So you get actually the correct value of the length. So X and X gets cancelled and you have L. So you see that this averaging actually gives you what? The correct length of the measurement. তোমার যে কারেক্ট লেন্থটা দরকার সেটা তুমি বের করে আনতে পারো, although there is error in the system. সিস্টেমে এরর আছে, there is error in the system, but still by this mechanism you can cancel out the errors and get the correct values. So this is just to show you some relevance with the with some other experimental views. Come back to our discussion of interference. Come back to interference. তাহলে বোঝা গেছে কেন একটা সোর্স থেকে দুটো সোর্সে ভাগ করা হয়েছে। Why from one source it is you get two sources. I invested 15 minutes time over here, which could have been easily invested somewhere else, and that would have helped me to complete the syllabus faster, right? So ঠিক আছে, একটা তো কিছু শেখা হলো, you have learned something, that why do you take the sources in this way and why not two candles? Because the errors on the two candles are not same. দুটো ক্যান্ডেলের যে disturbance, the disturbance on both the candles are not same at all the times, and that is why they are incoherent. But in S, whenever there is a disturbance, the same disturbance will go to them and it will get mutually cancelled, right? আরেকটা কথা বলে রাখি, most of the time we take d1 and d2 to be equal. So দুটোকেই আমরা ইকুয়াল নিচ্ছি, তাহলে এই যে ফেজ ডিফারেন্স যেটা ছিল that will come out to be 0, মানে তারা বেসিক্যালি সেম ফেজে থাকে। You may do so, এটা তুমি করতেই পারো, but you may use d1 d2 also. আমার জিরো করার উদ্দেশ্য নয়, জিরো ইজ নট মাই ইন্টেনশন, মাই ইন্টেনশন ইজ কনস্ট্যান্ট ফেজ, কনস্ট্যান্ট রাখবো, এটাই হচ্ছে আমার ইন্টেনশন, জিরো করার ইন্টেনশন নয়, ওকে? বাট ইউ ক্যান মেক ইট জিরো ফর ইউর সিম্পলিসিটি ইন দ্য ক্যালকুলেশন সিম্পলিসিটির জন্য আমরা জিরো ফেজ ডিফারেন্স রাখতেই পারি, উই ক্যান কিপ ইট ওভার হিয়ার। আচ্ছা ঠিক আছে, এবার তো লিখতে হবে, গল্পটা লিখি। সো লেট মি রাইট দ্য স্টোরি ওভার হিয়ার। Let us consider capital S to be a source of monochromatic, capital S to be a source of monochromatic light of wavelength lambda, লিখে নেবে lambda, of wavelength lambda. S1 is in the suffix, I write it in this way. S1 and S2 are two slits. S1 and S2 are two slits at equal distance. You may make it equal. Equality is a special case, but it is not a required case. Required now, but you can make it to make the system simple. S1 and S2 are two narrow slits, two narrow slits at equal distance, comma, that is I full stop E full stop, that is S1 and S2 behaves as coherent sources, because coherence is necessary in interference. Coherence আমাদের দরকার। In the next paragraph I go for, পরের প্যারাগ্রাফে আমি লিখছি, we will find the resultant effect at capital P due to the interference of the waves coming from S1 and due to the interference of the waves coming from S1 and S2, right? Let the wave at S1 be represented by by, let the wave at S1 be represented by, so how do you represent the wave at S1? We represent it as y1 is equals to a1 e to the power I omega 1 t, and y2 is equals to a2 e to the power I omega 2t. So this is how I represent the two waves. I represent the two waves at S1 and S2. So S1 আর S2 তে আমি দুটো ওয়েভকে এইভাবে রিপ্রেজেন্ট করলাম। Now you may ask that why exponential? So exponential will help out in the calculation. So instead of sine and cosine, exponential always helps in calculation. So that is why I have taken it. And you also know very well that exponential actually consists of both the sine and cosine effect. Exponential এর মধ্যে sine এবং cosine দুটো এফেক্টই আছে, তো সেই জন্য exponential থাক, কোনো ব্যাপার না, so nothing. So you may use exponential at its ease without any difficulty. So y1 is equals to a1 e to the power I omega t, and y2 equals to a2 e to the power I omega t, right? So you can do it very well. তো সেটা করা যেতেই পারে, ফাইন। আচ্ছা, সো এই হচ্ছে দুটো ওয়েভ, কোথায়? এগুলো S1 S2 তে। এইবার the waves from S1 after reaching capital P, দেখো the waves from S1 after reaching capital P will be, এই capital P তে যাওয়ার পরে কি হবে? It is a progressive wave. So what will the form of the wave after reaching P? So y1 will be a1 e to the power I, তাই তো, e to the power I, এই ওমেগা 1 to 1 হবে না, হ্যাঁ, ফেজ গুলো তো সেম হয়, the phases are same, so don't write omega, right, দুটোই সেম, হ্যাঁ। So omega t minus কি হবে? phi, the phase. What is the phase? You know that phase difference is 2 pi by lambda into path difference. It is 2 pi by lambda into path difference. So what is the path difference from S1 to P? S1 থেকে P কতটা path difference আছে? What is the path difference? X1 is the path difference. So what will be the phase difference? Kx1. K is 2 pi by lambda. And the waves from S2 after reaching P will be, what will be the nature of the waves? That will be a2 e to the power I omega t minus k of x2. So these are the two waves at the point capital P. এই যে এখান থেকে স্টার্ট করলো একজন, ক্যাপিটাল পি তে আসলো, এখান থেকে স্টার্ট করলো, ক্যাপিটাল পি তে আসলো। Definitely there is a phase difference between the two waves at the point P, because x1 and x2 are not same. They travel different distances. X1 and x2 are different, so obviously they will be at some phase difference at capital P. So obviously তাদের মধ্যে একটা phase difference থাকবে। So এইটা কি? These are the waves at the initial point, আর এটা কি? This is the wave after reaching the point capital P. এটা হচ্ছে capital P পয়েন্টে যাওয়ার পরে। This is after reaching the point capital P. Now let us see that what is the resultant effect. এবার তারা interfere করবে। So the net effect at capital P due to the superposition of the waves. So the net effect at capital P due to the superposition of the waves will be দরকার নেই। So that should be definitely, তাহলে সেটা কি লেখা উচিত আমাদের? y equals to, it should be y1 plus y2, কি তাই তো? y equals to y1 plus y2. Put the value of y1. y1 এর ভ্যালু বসিয়ে দাও। y1 এর ভ্যালু হচ্ছে a1 e to the power I omega t minus kx1. y2 এর ভ্যালু পুট করো I omega t minus kx2. I omega t minus kx1, I omega t minus kx2. So these are the two values that you put over here, right? Now you may take this common, e to the power I omega t. E to the power I omega t যদি কমন নাও তুমি, তাহলে এখান থেকে আসবে হচ্ছে a1 e to the power minus I kx1 plus a2 e to the power minus I kx2, right? এরকম আসবে, right? Understood? Now let us just proceed with this calculation. এবার এটা নিয়ে একটু প্রসিড করো, তাহলে কাজ হয়ে যাবে, so we will understand. Something I have missed, I should write over here what is k. I should write that k is 2 pi by lambda. Just mere simplifications only. শুধু simplification করছি, nothing more than that. I take the first factor to be a and the next one to be b. এটাকে আমি a minus ib বলছি, just I call it a minus ib. You will write it yourself. এটা নিজেরা লিখে নেবে what is a and what is b, right? এখানে লিখে নেবে, হ্যাঁ, a কি b কি লিখে নেবে. For any complex number, you know that how to reduce a complex number. Complex number has two parts. One is the phase part, another is the amplitude part. So this becomes a square plus b square, and this one is e to the power minus I phi, where you may write that phi to be, what is the value of phi? Phi এর value কি হয়? This is what you have studied in your classes of complex algebra in your higher secondary mathematics. It is tan inverse of b by a. Minus sign is due to this minus sign. ওখানে minus বলে এখানে minus ছিল. So e to the power I omega t root over of a square plus b square is the magnitude. Any complex number has two parts. One is the amplitude part and one is the phase part. So that is what I have written over here. Or you may write y equals to some capital A e to the power I omega t minus phi. So this is the resultant effect at the point capital P after the superposition of the two waves. দুটো ওয়েভ সুপারপোজ করে যাওয়ার পরে এটা হচ্ছে তাদের রেজাল্টেন্ট এফেক্ট. দিস ইজ দ্য রেজাল্টেন্ট এফেক্ট দ্যাট ইউ অবটেন এট দ্যাট পার্টিকুলার পয়েন্ট. সো দিস ইজ দ্য রেজাল্টেন্ট এফেক্ট দ্যাট ইউ অবটেন এট দ্যাট পার্টিকুলার পয়েন্ট. আন্ডারস্টুড? এটা হচ্ছে রেজাল্টেন্ট এফেক্ট আমরা যেটা ওই পয়েন্টে পেয়েছিলাম. এ অ্যান্ড বিটা লিখে নাও, বিকজ এ অ্যান্ড বি উইল বি রিকোয়ার্ড আফটার সাম টাইম, রাইট? বিকজ হোয়াট ইজ ইউর ক্যাপিটাল এ? অ্যাকচুয়ালি ক্যাপিটাল এ মানে কি এখানে? সো ক্যাপিটাল এ ইজ রুট ওভার অফ এ স্কোয়ার প্লাস বি স্কোয়ার হুইচ উইল বি রিকোয়ার্ড জাস্ট নাও. একটু পরেই কিন্তু কাজে লাগবে. তাহলে এটা হচ্ছে রেজাল্টেন্ট এফেক্ট. নাও হোয়াট ইজ দ্য intensity? What is the intensity and what is the intensity at capital P? So capital P তে intensity কত হবে? Therefore intensity at capital P, intensity at capital P, what is the intensity at capital P? So the intensity at capital P can be easily defined to be as intensity at capital P is equals to the amplitude square. You take it to be the amplitude square. Actually the intensity is proportional to amplitude square, but here we take the proportionality constant to be 1 for our convenience, right? Because presence of the proportionality constant is not going to yield any new physics. এখানে proportionality constant থাকলে কোনো নতুন physics তুমি পাবে না. So that is why I take the proportionality constant to be 1 over here. So in all the entire discussion in interference, that is interference, diffraction for the next 10 to 12 classes. So for the next 10 to 12 classes, I will be using intensity to be amplitude square. So intensity মানে আমরা amplitude square এটা ইউজ করব. Although intensity is not actually the amplitude square, but it is proportional to amplitude square. And where from did you learn it? You have learned it from the previous classes of waves. That is, আমি লিখছি দেখো মনে পড়বে, I equals to half rho c, মনে পড়ে, half rho c a square omega square. I hope that you remember half rho c a square omega square. So এই যে a square, so this a square. So a square is the expression of that amplitude square. So intensity is amplitude square. So that is what I obtain over here. ঠিক আছে রে, বোঝা গেছে নিশ্চয়ই? আচ্ছা, amplitude square মানে আমাদের এখানে a square plus b square. I have asked you to write the expression of a square plus b square. a square b square লিখে রাখতে বলেছিলাম. এখানে আছে a1 cos kx1 plus a2 cos kx2 whole squared plus b1 sin kx1 plus b2 sin kx2 whole square. Understood? b1 বলে তো কিছু ছিল না, সরি, সবই a1 ছিল, a1 a2, sorry, there is no b1. So this is a1 and this is a2. So if you square it up, you see that, so এটাকে স্কয়ার করলে একটু ট্যাক্টফুলি করতে হবে. I am not going to write all the steps, you will also not write. You will see that a1 square cos square and here is a1 square sin square. So they togetherly gives you only a1 square. a1 square cos square, a1 square sin square will give you only a1 square. Similarly, for the a2 square also you get the same, it is a2 square. And for the 2ab term, you see, you will take 2ab common, to me 2ab ta common nebe, and within the bracket it should be cos kx1, cos kx2. This is from the first square, and this is from the second square. Sin kx1, sin kx2. পাওয়া গেল দুইজনকেই, you got it. This is how you can write capital I equals to a1 square plus a2 square plus twice a1 a2, and the very important term over here, cos kx1 সেখানে এটা প্লাস হবে, তাই না, মাঝখানে প্লাস ছিল। So cos a cos b plus sin a sin b is cos of a minus b. So you got the most important contribution over here. আজকের ক্লাসের সবচাইতে ইম্পর্টেন্ট টার্ম হচ্ছে এইটা, বিকজ দেয়ার ইজ আ ভ্যারিয়েশন অফ ইন্টেন্সিটি এট দ্য পয়েন্ট অন দ্য স্ক্রিন। স্ক্রিনের উপর একটা পয়েন্টে ইন্টেন্সিটির ভ্যারিয়েশন আছে, দ্যাট ইজ হোয়াট ইজ দ্য ইন্টারফারেন্স এফেক্ট, এন্ড দ্যাট ইজ হোয়াট উই আর গোইং টু স্টাডি ওভার হিয়ার। এন্ড দিস ওয়ান আই কল্ড কোসাইন অফ ডেল্টা। So this is I called cosine of delta. What is delta over here? Delta is the phase difference between the two waves at the point capital P, where delta equals to, delta টা কি এখানে লিখতে হবে, where delta equals to k times of, k times মানে 2 pi by lambda, k times of x1 minus x2, তার মানে হচ্ছে phase difference. What is this? Phase difference between the two waves, phase difference between the two waves meeting at P, meeting at P, phase difference between the two waves meeting at P. So যেই দুটো ওয়েভ P পয়েন্টে মিট করে তাদের মধ্যে এটা হচ্ছে ফেজ ডিফারেন্স। এটার ফেজ ডিফারেন্স কত? হোয়াট ইজ দ্য ফেজ অফ দিস? এই প্রথমটার ফেজ হচ্ছে kx1. হোয়াট ইজ দ্য ফেজ অফ দ্য ফার্স্ট ওয়ান? ইট ইজ kx1. হোয়াট ইজ দ্য ফেজ অফ দ্য সেকেন্ড ওয়ান? ইট ইজ kx2. সো হোয়াট ইজ দ্য ডিফারেন্স অফ ফেজ বিটুইন দেম? সো ইট ইজ ডেফিনেটলি k of x1 minus x2. তাহলে এটাই এদের মধ্যে ফেজ ডিফারেন্স, k of x1 minus x2. Got it? So what is that? তাহলে এই kx1 minus x2 ডেল্টাটা কি? ডেল্টা is the phase difference between the two waves meeting at the point capital P. Is the phase difference between the two points meeting at the point capital P. Understood? And now I will discuss with you that why coherence is necessary. কেন coherence এখানে necessary সেটা তোমাকে আমি এখানটাতে বলবো। তার আগে আবার আগে দেখে নি, let us first see that what is the condition for capital P to be bright and what is the condition for capital P to be dark. Capital P টা bright বা dark হওয়ার কি কন্ডিশন আছে সেটাও আমরা এখান থেকে স্টাডি করব। We will also study that what is the condition to get bright fringe and the dark fringe. এই ট্রিটমেন্টটা তোমরা হায়ার সেকেন্ডারিতেও পড়েছো, you have done it in your higher secondary classes, but most probably with sine and cosine terms. So here we have tried to do it in a different way, in a general way, such that it can be applied in some other calculations also. Right, so let us now go for the next part of this calculation. Okay, so I put up the first heading over here, that is the maximum intensity or the bright fringes. So এরকম ভাবে হেডিংটা দাও, that is maximum intensity, or these are called the bright fringes. Okay, so I put it in this manner. So এইভাবে দেওয়া হলো that maximum intensity or the bright fringes. Now you see that what happens for this. So if I want to make this intensity maximum, as this intensity is varying with this phase difference between the 2 points, এখানে ডেল্টাটা কি আছে? ডেল্টা is the phase difference between the two waves, and you know that as x1 and x2 are changing, this delta is also changing. So you just look at the diagram once again, আর একবার ডায়াগ্রামটার দিকে তাকাও। Look at the diagram. So as this x1 and x2, suppose I am interested in this point. So as I am interested in this point, so definitely my x1 and x2 will change. Our x1 x2 টা change করবে, and once my x1 and x2 are changing, so definitely my delta will also change. And as delta is changing, this capital I will also change. So this is what you have to first understand. So as I am moving from one point to another on the screen, আমি যখন স্ক্রিনের উপরে একটা পয়েন্ট থেকে অন্য পয়েন্টে যাচ্ছি, as I am moving from one point to another, so definitely my x1 x2 are changing, and hence my delta is also changing. So as delta is changing, so what is happening is that, so delta টা যখনই চেঞ্জ করে যাচ্ছে, my intensity also changes. Now the question is, what is the position of this maximum intensity? So maximum intensity or bright fringes, when do we get this maximum intensity or the bright fringes? So I is maximum when cos delta is equals to 1. So সেটাই লিখছি আমি maximum intensity. I is maximum when cosine of delta this term equals to 1, because trigonometric function cosine is maximum value is 1. So let us proceed with the calculation. So this actually gives me delta equals to 2n pi, where n belongs to some integral values, n ta jekhane integer values আসবে. So this is the first condition that I obtain for this delta. So eta prothom condition. So at these values of delta I will have maximum intensity. That is for constructive interference. So I understand that. So I write it over here. That is for constructive interference. Constructive interference means bright fringes or the maximum intensity. That is for constructive interference. The phase, that is for constructive interference, the phase difference between the two waves, the phase difference between the two waves will be the phase difference for constructive interference at any point. The phase difference between the two waves will be what? Will be delta equals to, it can take the values of 0, 2 pi, 4 pi, comma dot dot dot. So at these values of delta you will see that at these values of delta you will see that there is constructive interference. The phase difference between the two waves is this. That means that is the two waves are in same phase. That is the two waves are in same phase. Two waves are in, that is the two waves are in same phase. দুটো ওয়েভ একই ফেজে থাকবে, that is the two waves are in same phase, because 0 means what? Same phase. 0 এর পরে আবার 2 pi, you know that 2 pi means a complete rotation, so that means again it comes to the same phase. So that is what are the values. Now for this delta equals to 2 pi, now এখন আমাদের delta equals to 2n pi আছে. So for delta equals to 2n pi you will have, what is delta actually? Delta is, you know that it is 2 pi by lambda x1. Actually it's better to put x1 differential x2, because I don't know that which one is greater. আমি তো আগের থেকে জানি না x1 বড় না x2 বড়. Actually I am interested in the difference of these two. So that is called a differential sign. So this means that if x1 is greater than x1 minus x2, if x2 is greater than x2 minus x1. So from here I will get this path difference, that is this delta. So delta comes out to be 2 pi, so if you just cancel, so this is twice n into lambda by 2. Just এখান থেকে পাইটা ক্যান্সেল করে দাও, so this pi gets cancelled from both sides, so it is twice n into lambda by 2. So what is this delta? So here delta is actually this x1 differential x2, that is the path difference between the two waves. So দুটো waves এর মধ্যে পাথের ডিফারেন্স কত আছে? Path difference is the path difference and phase difference are the deciding factor that whether the point will be of maximum intensity or minimum intensity. Path difference বা phase difference এটাই ডিসাইড করবে যে ওই পয়েন্টটা ম্যাক্সিমাম ইন্টেন্সিটি হবে না মিনিমাম ইন্টেন্সিটি হবে. So this is actually called the path difference between the two waves. Path difference. This is the path difference between the two waves. That is, you can write over here, which you have also studied in your higher secondary classes. So for constructive interference, comma, the path difference, so for constructive interference, the path difference at the point of interference, the path difference at the point of interference should be even multiple, of lambda by 2. The path difference should be even multiple, of lambda by 2. So for constructive interference, the path difference at the point of interference should be even multiple of lambda by 2. Can I even multiple? Because this is twice n. If you put n equals to 1, it is 2. If you put n equals to 2, it is 4. If you put n equals to 3, it is 6. So whatever be the issue, it is an even multiple of lambda by 2. So lambda by 2 এর even multiple হতে হবে. So for constructive interference, the path difference at the point of interference should be even multiple of lambda by 2. Right? So that is the condition for bright fringes. So একটা পয়েন্টে ব্রাইট কিনা কি করে বুঝবে? How will you come to know that whether a point will correspond to bright fringe or not? So the rule is that at that point the path difference should be even multiple of lambda by 2. And what is the value of that Imax? তাহলে একই রকম ভাবে Imax এর ভ্যালুটা কি হবে? the value of the Imax, you know that if you see that if you put this cosine delta equals to 1, so এখানে যদি cosine delta যদি 1 put করো in equation number 1, so then it is a1 square plus a2 square plus 2a1 it. That means it is a plus b whole square. So by 1 I write, so by 1 this one is Imax is equals to a1 plus a2 whole square. Simply a plus b whole square হবে আর কিছুই না, or this can be written as 4 of a square if this a1 and a2 are equal. If a1 is equals to a2 is equals to a, দুজন যদি ইকুয়াল হয় তাহলে এটা 4 স্কয়ার হবে if 4 স্কয়ার. Generally we set the two intensities to be equal. There is some reason behind it which I will be discussing within the next 5 minutes. That why do I set the intensities to be equal. Now let me just try to discuss the points of minimum intensity. So এবার আমরা ম্যাক্সিমামটা হয়ে যাওয়ার পরে মিনিমাম ইন্টেন্সিটি পয়েন্টটা আমরা ডিসকাস করে নিই. Keeping the same framework, minimum intensity I will write it dark fringes. So I write minimum intensity, আমি লিখছি minimum intensity, or I write over here dark fringes. Minimum intensity, or I write over here dark fringes. So I is minimum. So when will I be minimum? I will be minimum. I will be minimum when cos delta, that one will come out to be -1. These are the two extreme ranges of cosine delta. Cos delta to দুটোই range আছে, either +1 or -1. So I will be minimum when cosine delta is equals to -1, or you may write over here that is delta equals to 2n plus 1 pi, because you see that if you put n equals to 0, delta equals to pi, and cos pi is -1, you know it. So where n is any type of integer, যেখানে n হচ্ছে এক ধরনের integer. Got the idea? So that is for destructive interference. The phase difference should be, that is, so for destructive means dark fringes. So for destructive interference, the phase difference. So for destructive interference, the phase difference should be. So for destructive interference, the phase difference should be. So let me just check what did I write last time. কি লিখেছিলাম? So for the phase difference between the two waves, for destructive interference at any point, the phase difference between the two waves, should be, so what it should be? It should be, the phase difference between the two waves should be, that is delta equals to, if I just put the values, it is pi, 3 pi, 5 pi, comma dot dot dot. That is the two waves must be in opposite phase. Pi মানে কি opposite? That is the two waves, must be in opposite phase. That is the two waves must be in opposite phase. The two waves must be in opposite phase. That is what I mean to say over here. Okay, so now let me proceed with the calculation. Calculation ever kori. Now you know that delta equals to 2n plus 1 pi. So this means that this is 2 pi by lambda x1 differential x2, 2n plus 1 pi. So this pi gets cancelled, pi ta cancel হয়ে যাচ্ছে, or from here you have, বা এখান থেকে আমাদের আছে, this delta comes out to be 2n plus 1 lambda by 2. So that is what is the result in this particular case. So this is the result of the path difference. So এটাই হচ্ছে path difference এর result. তাহলে এই ক্ষেত্রে আমি কি পেলাম? So what do I get under these circumstances? So I understand that for destructive interference, the path difference should be an odd multiple of lambda by 2. So let me just copy this statement and make the requisite change. So for destructive interference, the path difference at the point of interference, should be odd multiple of lambda by 2. Should be odd multiple of lambda by 2. Should be odd multiple of lambda by 2. That's it. The minimum intensity is given by, and by 1 from this equation 1, What will be the minimum intensity under these circumstances? এই ডেল্টার ভ্যালু এই পাই হলে, if the values of delta is pi, that means when the two waves meet in opposite phase, যখন দুটো ওয়েভ অপোজিট ফেজে মিট করে তখন I minimumটা কত হবে? So I minimum will be a1 differential a2 this one whole square. How do I write differential? You know, because at the beforehand I don't know that which one is greater, whether a1 or a2. Equation 1 টা দেখে না, you just look at equation 1. If you put this cosine delta to be -1, so it is a1 square plus a2 square minus 2ab. So that is a minus b whole square. But I don't know which one is greater actually. So I write a1 differential a2. And you see that this one will turn out to be 0 when a1 is equals to a2. Okay. So now at this point I will also discuss with you that why do we take the amplitudes to be equal. Amplitude টাকে আমরা equal এই জন্য রাখি. I keep the amplitude equals in these two cases because the brightness can be understood properly if the dark point is completely dark. Dark পয়েন্টটা যদি পুরোপুরি ডার্ক হয় তাহলে সেখানে ব্রাইটনেসটা আরো ভালো করে বোঝা যায়. ট্রাই টু আন্ডারস্ট্যান্ড দিস. সাপোজ আই হ্যাভ টু অ্যামপ্লিটিউডস, ধরে নাও a1 is 5 and this a2 is 3. So then the maximum point, that is Imax. So what will be the Imax? So by this time we know that Imax is a1 plus a2 whole square. This will be 5 plus 3 8 square is 64. And we know that I min is a1 minus a2 whole square, that is 5 minus 3 is 2, so that should be 2 square is 4. So you see that the maximum intensity point is 64 and the minimum intensity point is 4, right? So তার মানে ম্যাক্সিমাম ইন্টেন্সিটিটা হচ্ছে তোমার 64 আর মিনিমামটা হচ্ছে 4. তার মানে ইন্টেন্সিটি ভ্যারিয়েশন হচ্ছে, and at the minimum point it is not completely dark. I call it dark fringes. আমরা dark fringe বলে থাকি, but in general it is not dark. Bright fringe is maximum intensity and dark fringe মানে minimum intensity, but not completely dark. বাট তুমি এখন এটা বোঝার চেষ্টা করো দ্যাট ভালোটা তখনই বুঝতে পারবো যখন আমার কাছে খুব খারাপ একটা জিনিস থাকবে. সো হোয়েন আই উইল হ্যাভ আ ভেরি ব্যাড এফেক্ট, দেন অনলি আই উইল আন্ডারস্ট্যান্ড দ্যাট হাউ গুড ইজ মাই আদার এফেক্ট, রাইট? সো দ্যাট ইজ ওয়াই উই অ্যাকচুয়ালি মেক the two amplitudes to be equal such that maximum intensity is maximum 4a square and the minimum intensity turns out to be 0. কারণ একটা যদি কমপ্লিট ডার্ক হয়, if one of them is completely dark, so then the other point will be brighter. So that is what will help me to understand the effect, right? তো সেটা আমাকে এফেক্টটা বুঝতে সাহায্য করবে, সেই জন্য আমরা কি করি, so that is why we make one of the point to be the maximum point. I make it to be sorry, not the maximum, the two amplitudes I try to keep them same such that the dark points come out to be 0, and with reference to 0 the maximum point is most maximum, মানে ম্যাক্সিমামটাও আরো বেশি ম্যাক্সিমাম তুমি করতে পারো if you can keep the amplitudes to be equal. Okay, so now I draw the intensity distribution pattern over here. Intensity distribution pattern. Intensity distribution pattern. So let us discuss the intensity distribution pattern. That what is intensity distribution pattern? So that means that I am basically plotting intensity versus that delta. আমি ডেল্টার সাথে ইন্টেন্সিটিটাকে প্লট করছি. Okay, so this side we basically plot, এইদিকে আমরা প্লট করেছি কি, this side I have plotted the intensity. This is the maximum of the intensity. So this point, it is the intensity maximum, which is 4a square in my case. 4a square is the maximum intensity. And in these points you see, এই যে points গুলো আছে, these are the points, dark points. এইগুলো হচ্ছে dark points গুলো. So where does the dark points occur? Dark গুলো কোথায় occur করে? The dark occurs at pi, 3 pi, 5 pi, or you may say the dark occur at minus pi, minus 3 pi, minus 5 pi, and these are my points. এটা হচ্ছে 0 pointer, so this is my point of 0. So hopefully everybody of you have understood what you need to understand. So jar ja bojar chilo nischoi bujhte perecho. I guess that you have understood the issues that has been laid. So এই জায়গাগুলো হচ্ছে dark points, and what are my these maxima points? So maxima point is at 0. The next maxima, you know, it is at 2 pi. The next maxima is at 4 pi. That is whatever I mark by blue, these are the points of maximas. So যেগুলো blue দিয়ে mark করলাম সেগুলো হচ্ছে maxima point গুলো, আর black গুলো হচ্ছে these are the dark points. আর intermediate points from 0 to pi, দেখো আমরা সবসময় in interference we actually speak of the dark fringe and the bright fringe, and in between them, so it is the intermediate effects. So তার আগে কিন্তু এই যে 0 তে, at 0 the intensity is maximum and then it gradually decreases, তারপর কিন্তু ওটা gradually decrease করে, তার মানে 0 আর pi এর মধ্যে যে পয়েন্ট গুলো, the point which are between 0 to pi, so there you find some intermediate intensity, and at pi you see again a complete 0. So that is what is the intensity pattern you actually notice on a screen, right? And if you can view it on a screen, you have this experiment in your course, in your CC4 practical paper, you have some experiments related to interference experiment তোমাদের কোর্সে আছে, and if you can go through those, তুমি যদি সেগুলো দেখো, you can view the fringes by your own eyes. তুমি তোমার চোখে ফ্রিঞ্জ গুলো দেখতে পাবে, তোমাদের কোর্সে সেই জিনিস কিন্তু আছে, it is there in your course. So if you want, you can view the fringes yourself in your experimental table. So the fringes will be something of this nature. So এরকম তোমার ফ্রিঞ্জ গুলো আসবে. So these shaded are the dark fringes, এরকম তুমি dark fringe দেখতে পাবে, and the unshaded are the bright fringes. So these are my bright fringes, these are my bright fringes, and these are my dark fringes. These are bright, these are dark. এটা bright, এটা dark, right? And you have to measure also the position with the help of the micrometers. So এগুলো তোমাকে measure করতে হয়, you have to measure all these yourselves in your examinations and in your laboratory classes. These are actually measured. So সত্যিকারই bright dark তুমি কিন্তু চোখের সামনে দেখতে পাবে, you will be able to see that bright dark fringes in front of you. Is it clear? Now I will be discussing that what is the distance between two consecutive bright fringes. So two consecutive bright fringe মানে, so let me fix the position. You see that the bright fringe has a width. Let me fix the position to be the midpoint. So midpoint is my reference point. So this is my reference and this is my reference. So what is the distance between two consecutive bright fringe? দুটো পরপর bright fringe এর মধ্যে কতটা গ্যাপিং আছে? What is the gapping? Suppose this is my nth fringe, and so this one is my n plus 1th fringe. So what is the intermediate gap between the nth and n plus 1th fringe? এই দুটো ফ্রিঞ্জের মধ্যে কতটা উইথ আছে? Or you may take the dark fringes also. So from the midpoint of one dark to another dark, so what is the distance over there? So this is the things that you need to calculate next, and this topic is known as the fringe width calculation. So let us go for the fringe width calculation next.